Hey guys, okay, so the next lesson we're going to do is special right triangles. And specifically, we're going to look at 45, 45, 90 triangles. Now, of course, there's an infinite number of right triangles we could look at, but we are really only going to focus in on the 45, 45, 90 triangle, which you've seen in geometry before, where we have our right triangle and then the other two sides are both 45 degrees. And we're going to talk about what are these side lengths. So why this is important and where it kind of comes from is because if you look at a square, what do you know about the side lengths of a square? They're all the same, right? So all four of these sides are the same. Let's call each side x. And what do you know about the angles? They're all right angles. So if you cut a square perfectly in half along the diagonal, like so, you end up with one 45, 45, 90 triangle, which I'll blow up right here. And if you recall from geometry, these angles are being bisected by the diagonal. So that means this is a 45-degree angle, this is a 45-degree angle, and then our side lengths will be x and x. So really, the only new question for us is, what is this hypotenuse? We'll go through the steps to find it. I would start with the Pythagorean theorem, is what I would use to find r. So I would do x squared plus x squared equals r squared. So we can combine our x's. We get 2x squared equals r squared. Take the square root on both sides. And you end up with the square root of 2 times by square root of x squared. X equals r. I'm going to switch these two guys around. So we get x root 2 equals r. And that is going to be our hypotenuse, x root 2. And in every single 45, 45, 90 triangle, that'll be true. The side lengths, these two will always be equal. That's why they're x and x. And this hypotenuse will always be whatever this length was, or this length, times by the square root of 2. So where this comes from, I could give you some problems. Let's say I told you the side length right here was 10, and I said, fill in the other 3 side lengths. So you would look at this and say, all right, this is 10. I know this has to be equal, so this would also be 10. And this hypotenuse is going to be whatever my x coordinate is, 10 times the square root of 2. So those would be the missing side lengths. So I'm going to let you try a couple of these. Find the missing sides. We'll try one here. So you'd plug in the 3 sides. You can pause it right here. Try this problem. Give you a sec to pause it. When you're back, here's how I like to do this. I like to write out what my 3 sides are generally. This would be x, this would be x, this would be whatever x is times the square root of 2. So if my x is 3, that means this x is also 3. And then this x is also 3. And those would be my 3 side lengths. So let's try number 2. Take a sec, pause the video, try the problem. Okay, again, I like to write down generally what all 3 sides are. X, x, and this would be x root 2. So what is my x coordinate here? Well, in this case, my x is 6. So that means this x is 6. And this x is also 6. Great. I'll give you one more example. Try this one. Pause it right here. So let's see here. I like to write down generally what all of these are. X root 2. So now my x is the square root of 5. So that means this is also the square root of 5. And this is the square root of 5 times the square root of 2, which would be the square root of 10. Okay, that's it. Hope that helped. Thanks, guys.